Hi, welcome to my session. My name is Bingji Miao. I'm a principal software engineer at Couchbase. And today I'll be presenting the N1QL Optimizer. So the quick agenda, we'll start with a quick overview of the rule-based as well as the new Couchbase Optimizer in N1QL. We'll spend a little bit more time on the new Couchbase Optimizer. Then we'll be spending a significant amount of time talking about the new update statistics or analyze statement, which is required for the functionality of the new Couchbase Optimizer. Then we'll move on to the output of the Couchbase Optimizer. And then we'll talk about the new settings for the Couchbase Optimizer, and we'll end with future improvements. So let's get started. Before Couchbase Server 7, that means Couchbase Server 6.6 and earlier, N1QL uses something called the rule-based optimizer or RBO. So the main functionality of the rule-based optimizer is index selection, which means given a query and the key spaces or collections referenced, the RBO is responsible for picking the best indexes to use to access each key space. So it uses a set of rules to pick the best index to use. And if there's no clear winners, meaning it cannot distinguish or cannot choose between, say, two indexes, what it does is going to pick both indexes and use something called the intersect scan with the indexes. So what happens then is at runtime, we'll fire up both indexes, and whichever index scan finishes first will then terminate the other index scans. So what happens effectively is the optimizer or RBO is delegating the decision for indexes, in this case, to runtime. So when joins are introduced in N1QL, the RBO is going to be using the nested loop join as the default join method, unless you specify something called the use hash hint. So hash join is the other alternative join method we support. So without any specification, N1QL is going to be using the default nested loop join. So again, the RBO is sort of delegating the decision of which join method to use to the user. You need to specify that in the query. Hash join, by the way, is only supported in Enterprise Edition as of now. And then if you have a more complex query with multiple joins, the order of the joins are executed is the same as the order that they are specified in the query. In other words, the rule-based optimizer is not going to do any kind of join reordering. So the Couchbase optimizer is introduced in the Couchbase Server 7.0, which is introduced earlier this year. So what it does is it's going to gather optimizer statistics using the new update statistics or analyze statement. And then it's going to calculate cost for the operators and the query plan, and then use the cost for choosing the best query plan to use. So compared with the rule-based optimizer, the Couchbase optimizer will be able to better distinguish among different indexes to use. So we talked about earlier, the RBO sometimes cannot distinguish between indexes, so it'll just use intersect scan with multiple indexes. CBO should be able to, based on the cost information, better distinguish among different indexes. And in theory, it should pick intersect scan a lot less frequently. And if it picks intersect scan, that's because it thinks it's a better method compared with just accessing with a single index. It does not pick it just because it cannot distinguish between different indexes. So a little bit more about the Couchbase optimizer. Again, it was introduced in Couchbase Server 7.0. So Couchbase optimizer has been used in relational databases for at least a couple of decades. And all major relational databases have some version of the Couchbase optimizer. So the relational databases went through sort of a natural evolution from rule-based optimizer to the Couchbase optimizer. Most of them started out with rule-based optimizer, just like we did. And then after a while, they all migrated to a Couchbase optimizer because of the advantages of a Couchbase Optimizer over the rule-based optimizer. So in Nickel or Couchbase, we're going through a similar evolution. We started out with a rule-based optimizer, and we're now introducing a Couchbase optimizer. So the Couchbase optimizer is available in Enterprise Edition only. It requires optimizer statistics that need to be gathered using the new update statistics or analyze statements. Based on the optimizer statistics, it's going to calculate a cost for the runtime operators. So it's going to calculate costs for things like index scan, intersect scan, nested loop join, hash join, filtering, group, sort, projection, etc. And then the cost of a query plan is just a cumulative cost of all the operators in the query plan. And it's going to make a decision or pick the best query plan based on the cost information. So that's at a high level of how Couchbase Optimizer works. So now let's dig a little bit more into the new update statistics or analyze statement. As we said, and this is a new statement, a Nickel statement to gather optimizer statistics. It is required for the proper functionality of the Couchbase Optimizer. The statement is currently user issued, which means user must issue the statement to gather the necessary statistics. It gathers statistical information for key spaces or collections, indexes, as well as distribution statistics on certain fields using sampling. When you have multiple query nodes, you only need to issue the update statistics command on one query node, and the optimizer statistics gathered from one query node will be available for all query nodes. There's going to be a new bucket, scope, and collection for use for the optimizer statistics gathered. So this new bucket, scope, and collection is called Nickel System Bucket, .Nickel System Scope, .Nickel CBO Stats. So this new bucket, scope, and collection will be automatically created the first time an update statistics command or analyze a statement is run. So this may look unfamiliar to you, but please don't drop it because this bucket, scope, and collection contains all the optimizer statistics gathered. If you drop it, then all the statistics gathered will be lost as well. If you indeed accidentally drop this new bucket, scope, or collection, it will get automatically created again the next time an update statistics or analyze statement is run. But as we said, all the previously gathered statistics will be lost. So when the new bucket, scope, and collection is automatically created, it is created with the minimum 100 megabyte of memory quota. So you want to sort of monitor the memory residency of this new bucket, scope, and collection. Since for a large system, when there are lots of documents in this new collection, it may fall under the 15% recommended memory residency. So if that happens, you want to increase the memory quota of this new bucket, scope, and collection such that it will maintain above 15% memory residency for smooth functioning of the new bucket, scope, and collection. So let's go into a little bit more detail on the syntax or how to use the new update statistics or analyze statements. So there are several ways of issuing this new statement. So on the right-hand side, I have several examples. So on the top there, you can specify a list of terms. So in many aspects, the new update statistics statement is very similar to the existing create index statements. So on the top example there, we're doing update statistics for airport, and this is using the new travel sample bucket, which contains a inventory scope now. And under the inventory scope, there's several collections for airport routes, etc. So assuming you are using the new travel sample documents, the first command there, you see update statistics, and the 4 keyword is optional for airport, and then in parentheses, you specify the terms, in this case, city and country. So this will just tell us to gather optimizer statistics on these specified field, city and country. There's a similar analyze statement right underneath. So this is very similar to your create index statement where you just specify the individual index keys. The next example has an equivalent to the array index key. So in create index, you can specify an array index key, and you can do it the same way or actually using the exact same syntax in an update statistics or analyze statement. So the second example on the right-hand side, we're doing update statistics for route. And then the term or the expression is going to be distinct array v dot flight for v in schedule n. Again, this is exactly the same syntax as an array index key specification in a create index statement. So the third way of using this is if you already have indexes created. So in the third example on the right-hand side, you see a create index statement on airport, on city, and country. So once that index is created, you can issue update statistics for airport and then specify index, the keyword index, followed by parentheses with one or more index names inside the parentheses. So when you do that, we'll just gather up all the index keys and then perform update statistics on all the individual index keys. So this is a convenient shorthand for issuing update statistics once you already have one or more indexes created. And the last option here, you can do this for all the indexes. So in the last example on the right-hand side, you can say update statistics for airport index all. So when you do that, we'll just gather up all the indexes defined on airport, gather up all the index keys, and perform update statistics on all the index keys. So the all index option is only available for collections, whereas the other options, you can do it for either a collection or a bucket. When you do it in a bucket, similar to the semantics, it just meaning that you're going to do it for the default scope and the default collection under that bucket. You can also specify an option for the update statistic command. Again, this is very similar to a create index with a with clause. So the example here shows update statistics for airport, city, country, and then we specify a with clause, and I have two options specified here, a resolution of 0.5 and a batch size of 20. So a resolution is just a percentage of the approximate fraction of the total documents in each of the distribution bins. So when we construct a histogram on the term or on the expression, we represent it using distribution bins. So the default resolution is going to be 1.0 or 1%, which corresponds to approximately 100 distribution bins. So when you specify a resolution of 0.5, that just means you want 200 distribution bins instead of the default 100. So this is a way of you getting a little bit finer granularity for the histogram you constructed for this specific term. Batch size is the number of terms that update statistic command is going to process on each pass. So because of the construction of the histogram requires sorting, and sorting requires memory, so update statistics is going to have a memory footprint. And we don't want this to interfere too much of a running system. So by default, update statistics is going to be processing 10 terms at a time. So that limits the amount of sorting memory it uses. In situations where you have a not very busy system, you have a lot of memory available, you can increase the batch size to something greater than 10. That just means the statement is going to be processing more terms at a time, and the statement will finish faster. Conversely, if you have a very busy system or you know memory is tight, then you can specify a batch size that's smaller than 10, which means that the statement is going to be processed less number of terms each time, use less memory, but the whole statement is going to be running longer because it has to go through more passes. So how do you know which term or which field to run update statistics on? For CBO to function properly, you must have optimizer statistics on all the relevant fields or expressions in a query. So on the right-hand side, I have 3 examples. On the top there, I'm doing a join between airport and route. And on the on clause or the join condition reference the FAA field from airport and the source airport field from route. Then I have a where clause that references the city field of airport. I also have an order by clause that references the airport name from airport. So all of these references will need to have optimizer statistics on them for CBO to be able to function properly. So for this specific query, you will need to perform update statistics on airport, which includes 3 separate fields: city, which is referenced in the where clause, FAA, which is referenced in on clause, and airport name, which is referenced in order by clause. For route, you only need 1 field, a source airport, which is referenced on clause. You notice the projection clause or the fields after select doesn't necessarily need optimizer statistics because all those fields were just taken directly from the document. We're not doing any sort of operation on them. So the optimizer doesn't really need more information on those. So the second example here is a simple query. We're just selecting from airport, but the where clause has lower of country equal US. So there is a function here applied to a field lower of country. So when you create index for this query, you include index key that has what we call the functional index. So index key will be lower of country. And very similarly, for the update statistic command, you'll also include lower of country. So again, very similar to create index, the update statistic command allows functions and other expressions to be specified as terms. And then the last example here, we have an any clause. So where any v in schedule satisfies v.fly equal FL121. So to create an index to satisfy this clause, we'll need an array index key. And the array index key will be in the form of distinct array v.flight for v in schedule end. So that's how you create the index key in a create index statement. And you'll need exactly the same expression or index key in the update statistics statement to satisfy the same any clause in this query. A few more examples here. So the query on the top, on the right-hand side, we're doing a nest operation. And again, to satisfy this, when you create an array index key, you have something like all array v.flight for v in schedule end. And again, for update statistics command, you'll be using exactly the same expression as a term in the analyze or update statistics command. In the middle example here, we have a with clause, and that's an syntax for what we call a common table expression, or CTE. And then after the S, it's a subquery that defines the CTE. So in this case, you need update statistics on the same expressions that we'll need for the query included as the subquery here. So again, since it only reference lower country, in the subquery part of the with clause, you'll be needing the same update statistics on only the lower country part for this query to work. On the bottom example here, we have a window function. So when you have a window function, you will also need to include the partition by and order by clauses for the window function. So in this case, example, we only have a partition by country. So in the update statistics command, we'll need to include country for airline here. So, so the examples I gave sort of gave you a sense of how you would gather update statistics or which fields you need. As we mentioned earlier, many times it is easier just to use the index option. So when you have update statistics for key space and the index, you can include the index names you will want. And then when you do that, you just need to be a little bit careful on the other fields or expressions included in your query that's not included in the index. So the next will cover dropping of optimizer statistics. So why do you want to drop statistics? So dropping of optimizer statistics can be used to turn off CBO effectively for either a specific query or set of queries. Because as we mentioned earlier, for CBO to work properly, you must have optimizer statistics on all the relevant fields and expressions. So if for whatever reason CBO is not working for you for a query or set of queries, you can just drop the necessary optimizer statistics. When that happens, then CBO will not kick in for that query or set of queries. So when you are dropping optimizer statistics, you can either specify a list of terms, as the top example shows on the right-hand side. So you can do update statistics airport, you can say delete and then a list of terms. So we'll just delete the optimizer statistics for the specified terms. Or the other options, you can drop the optimizer statistics for all the optimizer statistics for a specific key space or collection. So in that case, you can just say delete all, as the bottom example shows for update statistics. Or if you're using the similar analyze command, you can just say analyze airport delete statistics. So that covers the update statistics command. Now let's look at the output of CBO. In other words, how do you know whether CBO is in effect or not? And for that, you need to look at the explain. So when CBO is in effect, the explain output is going to contain a new object for each operator. And that object is called optimizer estimates. And when optimizer estimate is available for all the operators in the query plan or for the entire query plan, then we also print out the cost and cardinality information on top of the query plan. So that's sort of how you know that CBO is in effect for your query. It is possible, however, to have some operators with optimizer estimates and other operators without. For example, you can have an index scan that has optimizer estimates because all the necessary fields or index keys has the required optimizer statistics. But then later on, when you have a filter operator, you may not have the optimizer estimates object with it because some of the fields referenced in filter does not have the optimizer statistics associated with it. So that means for that query plan, part of the plan is using CBO and part of the plan is not. When you're missing optimizer statistics, then we just fall back to the traditional rule-based optimizer or RBO to construct the rest of the plan. So here is an example query plan. We're doing explain on a join query that joins airport with route. And I did not print out the entire explain because that takes too much space. I just put down relevant parts in it. So if you look at the lower part first, we have an operator called index scan 3. So that's doing index scan on one of the key spaces. I don't have information on which one it is, but it's doing index scan on one of them, either airport or route. And then other than the regular fields, we also have a new object called optimizer estimates. It has a few subfields in it. This tells you that for this specific operator, which is index scan 3, we're using CBO and CBO is calculating costs and other information for this operator. And then when you look at the top of the plan, just right above plan there, we also have cost and cardinality information. This means CBO is actually in effect for the entire query, and we're able to calculate the cost and cardinality information for the entire query. And when that's available, we also print it out for the entire plan there. So that's the way, how do you know when CBO is in effect or not, is to look at the query explain output. Okay, now let's go into a few settings for CBO. So CBO in Couchbase version 7, CBO is turned on by default. However, you won't get CBO functionality until you issue the necessary update statistics or analyze statements to gather the optimizer statistics. So if you do nothing, then CBO is not going to kick in because it doesn't have the necessary statistics. So once you run the necessary update statistics statements, then you'll be able to see CBO functioning in Explain as we showed earlier. There are a few settings for CBO that you can use. So at the cluster level in the UI interface, under settings, query settings, then advanced query settings, there's going to be a new checkbox for use Couchbase Optimizer. That's going to be checked by default, but you can go in and uncheck it if you don't want to use the new CBO functionality. You can also set this at the node level. There's a new setting called use CBO that can be set to true or false, and that will be effective for that query node. And then at the finer granularity, there's also a request level setting of query parameter use CBO, which can be set to true or false on a per request basis. So as usual, the request level setting is going to override the node level setting, which in turn overrides the cluster level setting. So there are settings at different granularities that allows you to control or turn on and off CBO as you like. So that covers the basic new CBO functionality. Now let's look at potential future improvements. So in Couchbase Server 7.0, joins are still evaluated in order they are specified, which means there's no join reordering yet in version 7.0. So for each join, CBO is going to automatically evaluate and choose the best join method for the join. We just don't yet reorder the joins. So in a sense, the user is still responsible for picking the correct join order in Couchbase Server 7. What we're working on currently is something called join enumeration, which will give CBO the ability to reorder joins. So it's going to have a much larger pool of candidates to consider, and it has a much better chance to pick up the best query plan for you. So once this is implemented and shipped in a future version, it should be able to, in a lot more cases, pick a better query plan for you. In other words, it's going to sort of shift the responsibility of picking the correct join ordering from user to the server itself. That's all I have for today, the presentation. Thank you for attending my presentation.